Hello everyone, in this video I will demonstrating how you are able to developing necessary analysis such as the residual plot to help you to examine if any of the model assumptions are related. So in my lecture video, I mentioned that in our textbook we mentioned about 6 assumptions, which are a little bit different from majority of the other analysis. We actually do not consider assumption 5 as the one for regression analysis if you don't use regression analysis for finding causal relationship. So therefore, in this video, we are focusing on assumption 1, 2, 3, 4, and 6, and I'll of course help you to learn how to find outliers. Okay, so the data set we're using is nothing new because in previous regression analysis computer skill lectures, we already look at this data set. So basically we are using the square footage, the number of bedroom, the age of the house, and the location to understanding to predict the housing price. Okay, so here I want demonstrating in terms of how to get regression because we're gonna base on the regression output to developing our residual plot, and then also a normal probability plot, and also a plot that we can use to find outliers. Okay, so under the data tab, and we'll go to the right hand side. So at this point, you should be very familiar with this process, right? We are going to data analysis, and under the data analysis, and we're gonna choose regression. So that is the function we use to get our regression output. So we pick a regression and click OK. So for my Y range, I will select from A1 to the last row, which is A379. And then so for my X range, since it's the multiple linear regression model, I will including everything for my X variable except my Y, right? So my X variable will including square footage, bedroom, age, Erie, Dallas. So the last two are dummy variables. And then don't forget to check labels because when I select the data, the first row what I selected are all labels. And then I will check, I will need a residual, standard residual, and a line fit plot, and don't forget normal probability plot. So we don't check residual plots. Residual plots will be helpful if you only have one X variables, okay? But if you have more than one X variables, please use the method I'm going to show you in this video to develop your residual plot. Okay, after you check all the boxes as I shown you in this video, and then you can click OK. Okay, great. So let me keep everything in 4 decimal places. Okay, perfect. Okay, let's see. So this is my result, and then let's look at the assumption one by one. So the first assumption, the regression model is linear in the parameter and the correlate is in a linear in parameter and the correlate correctly specified. That means are we able to see a linear relationship between my y and x variables? So one way you can examine this assumption is to look at every one of your line fit plot. Okay, so if you look at here, and then this is my second one. So the number of the bedroom here. I will delete the orange dots because the orange dot are my predicted value. So it's really very how to say, make the chart very unclear. Okay, so for the dummy variable, don't worry about it. So we're focusing on my quantitative data. Okay, so the relationship between square footage and the price, you can see an upward linear trend. And the bedroom, since we treat it as a quantitative data, but as you notice that they only have 3 options, 2, 3, or 4 bedrooms. And it seems like it's hard to say whether it's linear or not, but the most important square footage is linear. And for the age, it's linear, but it's very flat, okay? Okay, so this is one way you can do to understanding if the first assumption are valid or not is try to look at do you see your line fit plot? So your scatter are evenly distributed around your trend line, okay? So the second way, I think this is the way I actually prefer, is actually developing my residual plot. So in order to developing the residual plot, what you need to do is selecting predicted price and the residuals, these 2 columns, okay? once you select them, okay, so the predicted price and the residual, and you're going to here, insert, come here, add a scatter plot, choose the first one. Okay, so of course this chart is not complete because we do need to add in labels. So you can select the chart again, chart design, add chart element, including your primary axis, vertical, and horizontal. So this one always going to be my residual. And then this one will be the predicted Y, because in this case will be predicted house price. So this one is a better use because as I illustrated in our lecture, if X and the Y are not showing you a linear relationship, what you're gonna see is maybe a U shape upward or downward, or at least you don't see this kind of relatively like a horizontal band. So in this scenario, we know that for our first assumption, X and Y linear relationship will be hold. Okay, great. Now let's look at the second assumption. There is no exact linear relationship on the predictor. There is no multicollinearity. So to examine the assumption number 2 is not based on the residual plot. Actually, it's based on your, there's many ways to do. So in this class, we are focusing on based on your results, okay? We will look at my adjust R square, look at my F-test p-value, okay? My adjust R square is very large. My significance, again, adjust R square is almost very close to 100%, right? So it's a 87% variation in the Y that can be explained by regression model. If you look at the significance F-test, it's also showing the model itself is very significant. Okay, so at this point, there is a little bit warning sign because we're talking about if your R square is too large, maybe you need to go further to check on your coefficient. Do you have any coefficient that's supposed to be significant, but now it's not significant? Does any coefficient that's supposed to be a positive sign, but now actually end up negative? And or it's supposed to be negative, now it's positive. So if that also confirmed, that means there is a multicollinearity problem. Okay, now let's look at square footage in the bedroom. So both of them, based on intuition, should be positive. That's no question, right? So if you look at both of them, so they are positive, so the sign making sense. But then as you move on to look at the p-values, you will notice that square footage is significant, but somehow the bedroom is not. So ideally, the more bedroom, and then your housing price should be higher and should be significantly impacted. But unfortunately here, as you notice, it's not. So given the high value of R square, high significance of your F tests for the overall your model, and also you notice that the certain variable that's supposed to be significant but it's not, so that is a signaling us that we might have a multicollinearity issues. Okay, so if you will take applied econometrics down the road, so we're actually going to learn more formal tests like VIF to actually detecting multicollinearity in your regressor or predictors. Okay, so if you base on your tuition to think about x1, x2, you will know that they should highly correlate, right? The larger square footage, that might mean indicating you have more bedroom, right? The more bedroom also might relate to you have larger square footage. So x1 and x2 are highly correlated. We're not surprising, okay? Not surprising. Okay, at least based on this result, the high R square, high significant, and then we have variable that's supposed to be significant but it's not, and also based on our intuition, we identify variable they might highly correlated. So we are able to conclude that first of all, we will say we may have multicollinearity problem, and then further test will be required. Okay, the VIF test will be required. Okay, so this is second assumption, and now let's look at the third assumption. So basically for the third assumption, we're looking for the variance of the error term is the same for all observations. So based on my lecture, and in order to examine this assumption, we need to base on our residual plot. I already show you in this video. So this is my residual plot. So you actually have to create it by yourself by selecting the column, predicted price, and the residual, these two columns. Okay, the predicted Y and the residual. So what we're looking for is a horizontal band. So we don't see the variation of your residual decreasing or increasing. So basically we don't see this comb shaped, right? This kind of comb shape. So if we don't see a wedge shape or comb shaped, so that means this assumption is not validated. If you look at our residual plot, we actually are able to see this kind of horizontal band. We don't see any trend is the spread of the scatter getting narrower or spread of the scatter getting wider. So we don't see any of those. So therefore, our assumption 3, the variance of the error term is the same for observation, will be hold. Okay. So the last one, and the next one, assumption 4, conditional on predictors, predictor variables. The error term is uncorrelated across variation observations. So in order to examine the assumption 4, what we will do is we will create another plot. It's called a residual versus the order of observation. So in this residual output section, there's first column is called observation. Based on, basically, they are the order of my observations. Okay, what we're gonna do is we're gonna select the order observation, this column. Okay, after you do that, and then find the control on your keyboard, hold it, and then we're gonna select the residual column. Okay, after I select both columns, including labels, and I'm going to insert and I'm going to chart, and I'm going to choose scatter plot. Okay, this scatter plot. So basically what we are seeing here, the vertical axis is my residual and the horizontal axis is the order of my observation. So make sure we are adding the labels. So I also will call this one as residual versus the order of. And I also gonna click the chart design. I will add in my axis labeled primary horizontal, and then click again. I'm gonna add a primary vertical, and the vertical here is my residual. And then my horizontal here is order of the observation. So how do we know if this assumption is violated, right? So based on the lecture, we learned that if this assumption is violated, we will be able to see the big U shape. But now if you base on what we have here, also you can change your chart a little bit. Okay, let me actually changing my chart to this. It will be easier for you to detect. Okay, chart, change chart type. We're still going to my scatter plot, but I want to add in a line to connecting that. So scatter with the straight lines. Okay, so the reason I'm looking for this line is so that allow me to actually identify which one is the first, which one is the second. And then you will notice that there's no big U shape showing in this plot. Okay, so everything pretty random, go up and down, up and down, up and down. So we don't see any big U shape. So in this situation, the assumption for the error term is uncorrelated across observation will be hold, so it's not violated. Okay, so assumption 5, as I mentioned, that it become very important if you're using a model to prove X cause Y. If your goal is not that, and you don't need to worry about assumption 5. Now let's pay attention on assumption 6. So the error term is normally distributed. So to examine this assumption, we just need to use the plot called a normal probability plot that already developed when you're developing your regression output. So the Excel already named it called a normal probability plot. So what we are looking for is all the dots. So we have 400 observations, therefore it's very closely linked. So if you're actually able to stretch this chart very wide, and you will be able to see those dots a little bit. Okay, so when we are examining this this chart, our goal is try to see is all the dots fall approximately a straight line. Okay, of course, as you notice, it's not under here. We have 2 or 3 dots is like way below the line that we're supposed to be. As we get into the end, we also see a line tipped up instead of a straight line. So we're talking about when we have this assumption is so in this situation, the assumption is violated. And it become an issue when we are looking at F-test and T-test, because F-test and T-test based on the assumption is this has to be normally distributed. So in order to correct in this problem, you just need to add in more observations. Okay, adding more observations. Otherwise, your your f-test and the t-test might not be that accurate. Okay, so this is a normal probability plot to examine the last assumption. Of course, in this situation, this assumption is violated. Okay. Now, the last one I want to talk about in this video is how can you developing the chart to allow you to find outliers. So to find the outlier here, the method we're using is going to be based on the standard z-score, okay, standardize the value, which is our z-score. As we learned before, for the z-score, if it's larger than 3 or smaller than -3, we will consider that as an outlier. So we use that threshold to determine if we have outliers. So what we're going to do is, in the residual output section, we will have one column called the standard residual. Okay, and then we're going to create this called the standard residual plot. And we're going to select the predicted y value column and also the standardized standard residual column. After we develop the plot, we just need to focus on, do we have any residuals outside +3, larger than +3, or smaller than -3? Okay, let's select together. Okay, I select column predicted y, and I click Control and then start selecting my last column, which is the standard residual. After I do that, I go to Insert and go into Scatter Plot, adding Scatter Plot. Okay. Okay, let me stretch longer. So as you notice for this chart, my upper level here is 3, lower level here is the -3. So basically, again, this is a residual plot, right? Standard residual. So the vertical axis is a standardized residual and horizontal axis is predicted y. If you look at my chart, all my dots are within +3 and a -3. So therefore, we do not have any outliers. But again, please add in the axis labels, and we're going to click Chart Design, adding chart, primary horizontal, primary vertical, and then here we will have standard residual, and then here we will have predict. Okay, so now here they go. This is our standardized residual plot and allow us to find outliers. So in this case, we do not have any outliers. So to conclude this video, based on what we saw, for assumption 1 linear relationship, it's not violated. And when we look at there is no multicollinearity, so it seems like it might be violated because the number of the bedroom and the square footage might be highly correlated. So there we will have potential multicollinearity problem. When we look at assumption number 3, the variance, the arrow term is the same for all observations since we see a horizontal band. So therefore, the assumption 3 is not violated. When we look at assumption 4, so the arrow term is uncorrelated across observation. We're developing the residual versus the order of the observation. In that situation, in the chart we developed, we did not see the big U shape. Therefore, the assumption 4 is also not violated. However, when we look at assumption 6, the normal distribution, we look at a normal probability plot. It comes with our regression output, and we found not all the scatter are line up in a straight line. So therefore, assumption 6 is violated. And lastly, I creating the standard residual plot to find outlier, and we did not find any outliers. Okay, so this is the end of this video, and hopefully it will be helpful on your homework assignment and also help you on your class project. So good luck with your work. Bye.